This is the third part of the assembly design tutorial for adaptive formulations 2012, and the first two parts covered the basic directory structure for an assembly. For the purposes of this course, we're all going to be doing it the same way. We covered that, and also the basic workflow of making a product and making some contextual links within that product. Talked a little bit about why we're structuring the products the way we are. Again, the idea here is that we're making some component of a unitized facade, and the granularity of that wireframe gets to a finer and finer level the further down in the tree we go. So the overall wireframe is controlling the broad set out of the project. So there might just be a parametric surface and some lines that divide up that surface into a series of units, and then the next level of wireframe at the individual unit pulled in some of that geometry as a contextual link in tutorial 2, and that's where we're going to work from for now. So what I have here again is a master model at the top level. That's a product. We have a wireframe, a global wireframe within that, and then we inserted a product for an individual unit, and within that individual unit we have a wireframe that's controlling a kind of a finer grain of parametric behavior. So if we look at this, it looks a little bit more advanced from where I left off at the last end of the last tutorial. And what I've done here is I've created some parameters that control the edge offset. So I can change that edge offset to 200, I can change it to 300, back to 200. Right? So that we're starting to get at a wireframe that's got some level of intelligence to it, in that there's a certain set of parameters that control globally and a certain set that are controlled locally. And as I said earlier, we've worked this way a little bit in the past, where individual units are gaining specific knowledge from the overall product. So what we've done in the past is looked at attractor points, where the distance from an attractor point to a unit might determine that offset. So it can either be set manually, or it can read some geometry. We could pull in as an external reference this point. If I go into this part and I Control C and then right click, paste special as result with link, now it shows up here. That point is showing up as an external reference, and I could measure the distance from that external reference to some other piece of geometry in here and drive the edge offset, if I so choose, for some kind of parametric expression on this facade. But we're not going to do that for now. Today we're just talking about links and constraints. So the next phase of this is going to be to look at constraints. What I've set up here, as I said again, is a local wireframe, and on these wires I've built some axis systems. Okay, the axis systems are put there to make the constraint process easy. So what I can do is I can constrain a sketch to this axis system and then extrude that sketch along this length, right? And it just is really easy to index where exactly profiles are going in an assembly by using axis systems. The downside of that is that you have to be careful about how you build these axis systems. The convention that I've worked with is to keep the z-axis on an axis system in line with the extrusion. So what that means is that when I draw something on that wire that I want to extrude along that wire, I'm drawing it on the xy plane, and I'm extruding it along the z-axis. So the definition of that axis system, if I double click on it, you'll see that the z-axis is actually constrained to that wire, and the origin is of course on a point here at the center line of that wire. And I'm also trying to be careful that the orientation of all of these axis systems is consistent. So in this case, the y-axis is always pointing upwards or outwards, and the x is always facing outwards. And that will allow me, when I constrain my steel profiles to these axis systems, they'll all be facing in the same direction. So you do want to take care when you're building those axis systems to make sure that you're consistent in how they are put together. With the z-axis always pointing perpendicular to the actual plane of the profile itself. So that'll make more sense when we constrain some geometry here. So that's how I've set up this wireframe. I'll make this wireframe available on the Ning website for download so that you guys can look at it. Actually, I'll put this whole product structure up there so that you guys can have a look. So the next and I guess final, oh, just to back up for a second. The other thing that I did is you'll see these blue planes at the corners. Those are miter planes. So I know that what I'm going to do, you don't know this, but I know this. What I'm going to do is I'm going to extrude some standard steel profiles along these curves. And what I want to do is miter them at the corners. So I put some planes in my wireframes that are bisecting these two curves so that I can have a mitered corner there. So the next thing that we're going to do is double click on the the unit template, AF 2.2 unit template. Okay. And what we're going to do is we're going to insert existing component. Okay. I'm going to cancel just to show you that again where that all is. Double click on the unit template product. Make sure you don't have the master model product active. It's going to insert the existing component or the existing part in whatever product is active. So you double click on that, it turns orange. Go to Insert, Existing Component. And last week I showed you guys, and actually we distributed a directory that's got a whole bunch of master sketches in it. So if you go to the KnowledgeWare folder in our project directory, and just grab one of these steel sections. So just so you know, the C's are channel sections, steel channels. HSS is a steel tube, and the L's are angle sections, L-shaped. So we're going to use, for this model, let's use an HSS 5x3. Libraries of profiles, of steel profiles like this, are usually available actually with a CATIA license. If you do a little bit of digging in your directories, and we can actually look at this in class, you're probably able to find, I'm not sure if the educational license has this or not, but you're probably able to find a steel catalog, so you wouldn't even need to use all of my sections here, but just in case, let's just use those. So we're going to open HSS, and what it did, if you look in the tree, is it inserted this sketch, or this component. It was an existing component, it inserted it in our unit template. And if I actually right click on that and go to reframe on, it's showing me where it's putting it. And it actually put it right here. Sometimes it'll put it over here, sometimes it'll put it off at another origin. It kind of depends on how your product structure is set up. But what we want to do with this is we want to constrain it to this axis system over here. Okay, so it's actually quite easy to do that. If your axis systems are set up properly, it's actually quite easy to do that. So what we want to do is be in the context of the unit template. Do not be in the master model context, because we're making this constraint within the unit. We're not making the constraint within the overall master model. The first thing that we want to do is we want to fix the wireframe. And the reason we want to do that is what might happen is actually if I try to make a constraint between this steel section that I just put in and my wireframe, it actually might move the wireframe and not the steel section. What we want is vice versa. We want the steel frame to move to where this axis system is. And to make sure that happens, we're going to fix the wireframe. And it's good practice in general to fix one component in your assembly, and then everything else is constrained relative to that component. So we need to make sure that we're in the assembly design workbench. Right here, assembly design. And what we're going to do is we're going to make a fixed constraint. So this anchor here, very literal. I'm going to click that, and when it turns orange, you can see on the bottom left-hand side of the screen it says select the component to be fixed. So I'm going to select the wireframe. Okay? And what's happening, I'm sorry, I have some dead constraints here. What's happening is now this wireframe, the Unit A wireframe, is fixed in that context. And let me do a little bit of housekeeping here. My part is not named properly. So Unit A, we wanted to call it wireframe. If you remember from the previous tutorial, this is what we called it, and I didn't keep up here. So let's click apply. Yes, okay. So now that component is fixed and it's got its proper name. So we're in the context of the unit template. All right. One thing we might do is we might actually hide the global wireframe just so we're a little bit more clear, just to make things a little bit more clear with what we're actually doing. So in the context of unit template wireframe, I'm sorry, of the unit template product, so I have this highlighted in my tree, I'm going to click the coincident constraint. And the first time you do this, it pops up with this little assistant, and it's going to be really annoying, but it kind of tells you what the tool is going to do. Click do not prompt again in the future, close. And when you're constraining things relative to axis systems, you need to select the first one in the tree. So our goal, I have active right now this coincidence constraint. On the bottom right hand side of the screen you can see the tool that's orange there. That's the active constraint right now. And on the bottom left hand side of the screen it says select the first geometric element of the coincidence constraint, a point, a line, or a plane. But we can actually, it's not telling us, but it actually will also allow us to select an axis system. But if I try to do it graphically, it's not going to let me select the entire axis system. Instead, it'll select one axis or one plane of that. So what I want to do is go into that section that we just inserted, and in the tree select the absolute axis system, and then graphically I can over here click the axis system on that wire, and you'll see it'll jump over there, and it's now constrained, and it's fully constrained. It's not going to be able to move from there. Okay, so that is how you make a constraint. There are a lot of other ways you can make constraints between parts. You can constrain a point to a point, a line to a line. You can do a lot of different kinds of distance constraints, contact constraints. So I invite you to, as you're exploring this workbench, to look at these different kinds of constraints and just play with them and see what they do. They're pretty logical. There's a contact constraint. So if you have two surfaces, the contact constraint will just say that they're in contact with each other, which means that they can move relative to each other as long as the surfaces are touching. The offset constraint is exactly what you think it is. Two things are offset from each other, planes or surfaces. So there's a lot of different kinds of constraints here, but today we're just looking at coincident constraints, and it shows up in the tree. Let's now, remember we talked a little bit earlier about the difference between instances and just regular part numbers. In the context of the unit template, we're going to copy this HSS sketch. So Control C, Control V. We're going to paste them into that. And I got 4 of them now, right? So I've got 1, 2, 3, 4. And it's pasting them right on top of each other. But what we're going to do is we're going to constrain them to these other axis systems. So let's just do the exact same thing 4 times. What I'm going to do is take this instance number 2 of that sketch and click on the coincidence constraint tool and select in here absolute axis system, let's do it for number 3. Absolute axis system. And that one. And let's do it for number 4. Absolute axis system and that one. Right. And what I'm going to do now is I'm going to save. But actually, if we just so you know, if we go to File, Save Management, notice that we don't have any new files because remember we inserted an existing component. So these HSS sketches, these steel profiles that came out of the knowledgeware folder, are not new files. We just constrained existing files within the assembly that we're building. So what's getting modified is the product that we put it in. The product now knows it has to look for these files in the knowledgeware folder. But the individual files themselves are not modified. So I'm just going to click Save, and it's going to save everything. I'm going to click OK. It's basically now we have 4 instances of this steel profile. Now if we want to build some actual steel geometry, we are going to insert a new part. And we're going to insert that new part in the unit template product. And we're going to see, now this becomes important. It's going to ask us where we want to put the origin for that. I'm going to click No for now. But what it's going to do is you can see it's inserting that part in this location at the center of the panel. I'm going to want to constrain that right off the bat. And these constraints get a little bit cumbersome in that you have to define them all, but that's worth it down the road, because what we're going to do is we're going to make a template out of this whole panel and instantiate it across the rest of the facade. So it's not so bad. So let's click the coincidence constraint and absolute axis system, and we're going to constrain it to this axis system. Right? And what we're going to do is we're going to call that part HSS01. You can call it whatever you like. Whatever your naming convention, and I would encourage you to be as rigorous as possible with these naming conventions. And now this is actually a new part, so we're going to have to save that. So we go to File, Save Management. See, it shows up here as a new part. So we're going to save that in the unit folder. So go to 3D, Master Model, Units, Unit Template. I'm going to save it in there. Click OK. Don't worry about it. All right. Now we have this part, and all we're going to do is make a solid extrusion of this profile along this axis. To date, you haven't really done much in the way of solid modeling. We'll talk more about the fundamentals of solid modeling in class, but for now, let's just do a basic operation. So let's go to Start Menu, Mechanical Design, Part Design. New set of tools shows up over here, and basically solid modeling is dealing with actual solid geometry. It's another thing that makes CATIA unique, although there are other softwares that deal with solid geometry. CATIA is one of them. Solid geometry actually has the properties of solid, as opposed to just dealing with empty surfaces, lines, and points. So there's a tool up here called Pad. Click on Pad. And we're going to click on this profile. And what we're going to do with this pad is we're going to extrude it, but we're going to limit it to these 2 miter planes. So let's go up to plane. See the option here? You have a number of options for how you want the limits to happen. You can either type in a dimension, or you can do some other options. But let's click up to plane and click this plane. And then there's a More button down here that lets you define the other direction. We're going to do also up to plane. We're going to go to this plane. Click OK. And there's our solid. And really that's it. So this thing now is an individual part that is constrained to a unit wireframe, and the unit wireframe is being driven by a global wireframe. This individual part, if I actually right-click on that new extruded piece of steel, I can open it in a new window. And I can come in here and I can deal with this part all by itself. I can deal with chamfers or fillets or holes or machining operations or drawings or whatever needs to happen to actually get this part manufactured. I deal with it by itself as an individual part. It's got its own name, and it's going to be unique in the project. And if I just close that window, I actually don't even need to save it because it's still open, as it says here in the warning box that I got. Still open in this assembly. So there's that part. I can also right-click on my unit template file, open a new window. So go down to Unit Template Object, open a new window, fit all in. So here's my unit template open in a separate window, and I can work on just this unit template and get my the rest of my parts built, which is what we're going to do right now. So let's insert new part. We're not going to worry about where it goes right now. We are going to call it HSS02. Okay, and we're going to be in here, and we'll make a link. So let's make a pad. Actually, back up for a minute. We need to constrain it. I forgot to constrain that part. So we're going to constrain that part to, let's build it on top of this section down here. So we're going to build a coincidence constraint between this axis system and this axis system. There it is. Now we're going to go into that part, and we're going to make a pad, and we're going to select this profile up to plane here, and we're going to go more in the second direction up to plane here. Click OK. And you can see our miter joint, and you can also see, because this geometry, and this is something that you learn and that's really wonderful about modeling at this level of accuracy, is you see they're not exactly, it's not a perfect miter. And the reason is that the way I have the geometry set up and the kind of nature of the geometry of this design is that those can't be exactly a perfect miter. So maybe we can talk a little bit more about that in class and what a detail might be to resolve that kind of joint. But I would go up to File, Save Management, and save out this new part, Save As. New 3D Master Model, Units, Unit Template, HSS02. Click OK. Right. Now here we are back in the global context of the entire assembly, and the one last thing I wanted to show you that we covered a little bit in class was scenes. This is not critical for this assignment, although it will become critical for some of our future work. If we go to File, Mechanical Design, Infrastructure, Product Structure. We have to go to Assembly Design. My mistake. Assembly Design. You're going to see down here the Scenes browser and Enhance Scene. Pull this little toolbar out. What we want to click on is Enhanced Scene. And what this is going to do is basically a scene is something that is a feature of a product. And what it does is it overloads the graphic and positional attributes of parts in that assembly for the purposes of illustration. So The way we use these usually is to build exploded axonometric. So if I want to take this assembly and blow it apart as an exploded axon, this is the way to do it in CATIA. So we're going to click, make sure it says partial, not full. I'm going to uncheck automatic naming, and I'm just going to call it test exploded axon. Okay. Okay, don't worry about that warning. Now, remember earlier I showed you how to move things with the compass? Well, this is where it becomes really handy. So if I drag that compass onto one of my steel members here, what I want to do is I want to move it in the context of this unit template. And I'm going to highlight that part that I want to move. I'm going to double click this compass, and I'm going to say in the W direction, which is the long axis of this compass, the up and down axis. I want to move that thing in 100 millimeter increments. So boom, 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 boom. And then I'm going to drag the compass over here, and I want to move this part, and I need to highlight that part in 100 millimeter increments. I'm going to click close. And there's my exploded axon. So we have two parts in here. It's not going to look like much for an exploded axon, but once we build up more in this assembly, we'll be able to see, just how useful this is. So I'm just going to exit out of there. And you're going to see it's going to show up actually under applications in the master model. So you can see applications, scenes, test exploded axon is actually a feature in the tree. If I double click on that, it brings me back into the scene. It's exploded. If I exit, it all snapped back together. I think that about wraps it up for this set of tutorials. And I hope it's all clear to all you guys. We'll answer more questions in class on Tuesday, and have fun. Thanks.